Assalamualaikum warahmatullahi wabarakatuh. We are from Fastactive group. We'll explain replacement algorithm that contain FIFO, OPT, LRU and clock algorithm. Before we go to the next part, I will introduce all my team members. The first one is Nur Ashikin binti Shafie. Second, Nur Fatihah binti Yahaya. Third, Laila Mastura binti Ahmad Zabidin. Next is Basyiirah binti Mohd Zawawi. And I'm the last one, Najihah binti Yahaya. So, I will pass the next part to my friend.
Alright, let's start our discussion with FIFO page replacement algorithm. FIFO is the short term for first in, first out. It is the simplest page replacement algorithm. In FIFO page replacement algorithm execution, the rule that will be applied is that the longest page in the memory will be replaced. Now, I will show the example on how FIFO is executed. The page string we will be using is 3, 7, 5, 6, 5, 4, 3, 2, 4, 3 and 5. We will use 3 frames, assuming the RAM consists of 3 slots only, and we will use the character F to represent page fault. Page fault is when data is transferred from hard disk to RAM. It occurs after the frame allocation is filled. Now, let's start with page stream 3. Initially, the slots will be empty, so 3 will be allocated to the first empty slots. Next, 7 will be allocated to the second empty slots, and 5 will be allocated to the third empty slots. Now, all the frames has been filled. So, when 6 comes, it is not available in the memory, so page fault occurs, and it replaces the oldest page in memory, which is 3. Next, when 5 comes, it is available in the memory, which means it's a page hit, so no replacement occurs. Next, when 4 comes, it is not available in the memory, so page fault occurs, and it replaces the oldest page in memory, which is 7. Next, when 3 comes, it is not available in the memory, so page fault occurs, and it replaces the oldest page in memory, which is 5. Next, when 2 comes, it is not available in the memory, so page fault occurs, and it replaces the oldest page in memory, which is 6. Next, when 4 comes, it is available in the memory, which means it's a page hit, so no replacement occurs. Next, when 3 comes, it is also available in the memory, which means it's a page hit, so no replacement occurs. Next, when 5 comes, it is not available in the memory, so page fault occurs, and it replaces the oldest page in memory, which is 4. Now, the FIFO page replacement algorithm has been executed, and the FIFO policy produces 5 page faults after the frame allocation has been filled.
In optimal policy, whenever a page fault happens, the page to be replaced is the page with no next use or the last page to be used again. This algorithm needs the processor to know the sequence of the data stream beforehand to know when will a page be used again. To understand this algorithm better, each page in the memory is marked with an integer which shows when it's next used. With the current data stream, initially we have 3 in the memory, and since it will be used again in 6 steps, it is marked with 6. Next, we have 7. It will not be used again, so we mark it with 0. Next is 5, and it will be used again in 2 steps. Next is 6, and as the memory is currently full, a page fault happens, and 6 will replace 7 in the memory because 7 will not be used again. Next, we have 5, and since 5 is already in the memory and would be used again in 6 steps, we remark it from 1 to 6. Next is 4, and the memory is full and a page fault happens. Since 6 will not be used again, 4 will replace 6 in the frame, and since 4 will be used again in 3 steps, we mark it with 3. Next is 3. Since 3 is already in the frame, we just remark it from 1 to 3 as it will be used again in 3 steps. Next is 2. Memory is full and page fault happens. Currently inside the frame, all pages will be used again. So the page to be replaced is 5 because out of the 3 pages, 5 is the last page to be used again. Hence 2 will replace 5, and since 2 will not be used again, we mark it as 0. Next is 4, and it is already inside the memory, so we just update the mark. As 4 will not be used again, it is marked with 0. Next is 3, and it is the same as 4 previously. Lastly, we have 5. The memory is full, and since all pages currently in the frame will not be used again, technically 5 can replace any pages, but by default, it will replace the top page. In this case is page 3. Also, a page fault happens. In total, using optimal policy, we would have 4 page faults only. Compared to other algorithms, optimal policy is certainly the most effective in avoiding page faults. However, as this algorithm needs the processor to know the data stream beforehand, it is impossible to be implemented in real life. It is because a computer cannot predict the future.
I will explain about LRU. LRU stands for Least Recently Used. Least Recently Used algorithm is a page replacement technique used for memory management. The page that has not been used for the longest time in the main memory will be selected for replacement. This algorithm is easy to implement. This algorithm makes use of the counter along with the event page. Here is an example of LRU that I will explain. This example consists of a frame size of 3 and string number of 11, which are 3, 7, 5, 6, 5, 4, 3, 2, 4, 3, and 5. First, we have a string value of 3. This value will take place in the memory of the frame, which is at the bottom, so there will be a page fault. Next, we will proceed with the string value number 7. The string value number 7 will take place in the memory frame above the number 1, and there is also a page fault. For the string value number 5, it will occupy the empty space in the frame at the upper part of the frame. There is also a page fault. Next, we have a string value of 6. Since string value number 3 is the least used, the number 3 will be replaced by the number 6, and there is a page fault. The string value of 5 is already in the frame. It will take the existed place in the frame and will not replace any value in the frame, so there will no page fault. Proceed with the string value number 4. It will replace number 7, which is the least recently used, and there is a page fault. For the string value number 3, number 3 also will replace the least recently used, there is number 5, and have a page fault. For string number 2, it will replace the number 6, which is the least recently used, and there is a page fault. The string value 4 is already in the frame, so it will take the existed place in the frame and will not replace any value in the frame, so there will no page fault. The same goes for string value number 3. It will take the existed place in the frame and not replace any value in the frame since it is already in the frame memory. Lastly, for the string value number 5, it will replace number 2 since number 2 is least recently used and there is a page fault. So the total number of page fault for this LRU algorithm is 8.
Now I will explain about clock replacement algorithm. And we have 11 number of pages, and the page streams are 375, 654, 324, 35. First, 3 will be added in the first frame. It has the use bit, and the arrow pointer will be pointing towards the second frame. Next, number 7. Number 7 will be added in the second frame, and the arrow pointer will be pointed towards the third frame. Next, number 5. Number 5 will be added in the third frame, and the arrow pointer will be pointed towards the first frame, which is number 3. Next, Since all the number has the use bit, number 6 cannot replace them. So this is how we do this. So this is the step. If an attempt to replace a frame with use bit, the frame will lose its use bit and the arrow pointer will move to the next frame. And this is exactly what happened to the number 3. So number 3 lose its use bit and the arrow pointer will point to the second frame, which is number 7. Next, number 7 also lose its use bit and the arrow pointer pointed towards number 5. Next, number 5 also lose its use bit and the arrow pointer will pointed towards the first frame, which is number 3. Since number 3 doesn't have the use bit, number 6 can replace number 3. So the result will become like this: 6 and the use bit in the first frame, and the arrow pointer will pointed toward the second frame, which is number 7. Next, number 5. Since we already have number 5 here, so we just added the use bit here, and the arrow pointer will not move. Next, number 4. Since 7 doesn't have the use bit, and the arrow pointer also pointed towards the second frame, which is number 7, 4 just replace the 7 here, and the result will become like this, and the arrow pointer will pointed toward the first frame. Next, this is exactly what happened before, and I show you on how we do this. Okay, first, 5 will lose its use bit, and the arrow pointer will point toward number 6. Number 6 here also lose its use bit, and the arrow pointer will point towards number 4. Next, number 4 also lose its use bit, and the arrow pointer will point toward number 5 in the third frame. Since number 5 in the third frame doesn't have the use bit, number 3 here can replace it. So the result will become like this: 3 and the use bit in the third frame, and the arrow pointer will point towards number 6 in the first frame. Okay, next, number 2. Since 6 doesn't have the use bit, number 2 can replace it here, and the arrow pointer will point to the number 4 in the second frame. Next, number 4 of page 3. Since we already have number 4 here, we just added the use bit here, and the arrow pointer will not move. Next, number 3. Since we already have the 3 and the use bit here, nothing will happen, and the arrow pointer also will not move. Okay, next, last but not least, number 5. This is exactly what happened previously also, and I'll show you on how we do this again. Since number 4 here, it will lose its use bit, and the arrow pointer will point towards the number 3. Next, number 3 here also will lose its use bit, and the arrow pointer also is pointing towards the first frame, which is number 2. Next, number 2 also lose its use bit, and the arrow pointer will point towards the second frame, which is number 4. And since number 4 here doesn't have the use bit, number 5 can replace it, and the result will become like this, which is 5 and the use bit in the second frame, and the arrow pointer will point towards the third frame, which is 3 here. So the result is like this. I hope you understand how I explain this, and thank you.